Hey everyone, thanks for coming. This is amazing. So I thought I'd try something a little bit different today. I've given a few workshops on NumPy Pandas before, that kind of thing, but usually I'd have a block of 6 hours. And here we're limited to 2 hours. So what I'm going to do is maybe something a little bit dangerous. Who's heard of pair programming? All right, who's heard of mob programming? All right, mob programming, you take the pair and the other person is everyone else. I'm going to pair program this with all of you in the room at the live as we go. I saw a couple of gasps over there. We'll see how that goes. Alrighty, so first of all, a quick systems check. Does everyone have a working Pandas install? Anyone who does not have the ability to run that line? All right, if you don't, I recommend using Conda. Anaconda, so if you go to continuum.io, you can download it there. It's wonderful, it's fast, it's free. If not, pip install pandas, assuming you have Python working. And just while people, yes?
I 2.7?
I prefer 3. These slides should work on both, but if you have the choice, go 3.
Oh, let me interrupt a minute. So if there's questions, I've got the microphone here so people can hear. We're also live streaming, so if you speak to the mic, then people listening to the live stream can hear what you're asking. And and if you're on the live stream, I'm going to be monitoring the Twitter, which is the @PyDataSeattle 2017. So ask your questions there. Sorry to interrupt.
Thank you. Alrighty, so just while the last few people get Pandas installed, I'd love to do a quick show of hands. How many people consider themselves academics? How many people are software developers? All right. How many of you have used Pandas before? Okay. This is where I say I will not get offended if you'd like to leave the room to go to a more interesting workshop. I'm going to take you from the ground up here, okay? So no worries about that. Okay, and this is how we're going to do it. I'm going to have cells like this, and I can type in them, and I'm just going to be able to run them in real time. Cool. All right, I'm assuming everyone's done that line now. So a little bit about me while the last few people install. As was said in the introduction, I consider myself a lapsed computational physicist. I have a PhD in computational neuroscience, and then I worked on some statistical problems in disease transmission at Princeton. And now for just over a year, I've been a data scientist with CBRE. I also run the advanced topics on machine learning interest group in Seattle. If anyone's based in the Seattle area, come join us. All right, a little bit about the hero of the story. I love coffee. I am completely addicted to caffeine. And during my PhD, this was my best friend. Now, I worked in a small department at the University of Warwick, and we had this wonderful espresso machine. It was wonderful for 2 reasons, and one was that it gave us wonderful coffee on demand, and 2 was that it had this little display, and then you could hit a few buttons, and it would tell you exactly how many espressos it had brewed to date. So, we wrote an Android app. We sent it around to people in the department, and we said, when you go get a coffee, just interrogate the machine and tell us, and put into the Android app how many coffees it's on right now. And this started at about coffee 400, and it ended at about maybe 27,000. This is about standard for a maths department. So what we're going to do today is we're going to walk through an exploratory analysis, just a basic analysis of the time series that came out of this coffee data set. Let's tell you a bit more about that. So we're going to be doing this as a way to expose you to the Pandas API. Pandas is a huge package, very powerful, and it can do a lot of things. We're going to try to use it in a natural way such that by the end, if you've never seen Pandas, you have a good idea for how to work with it, get a feel for it. Slides are available at this GitHub link. There are 2 notebooks. One of them is the one I'm running through now. And one of them is called Solutions, and that one contains what I'm hoping I'm going to type at the end of this. If you want to follow along, please do. If you want to skip ahead, that's fine. And the Pandas documentation is really wonderful, so don't hesitate to Google things as you go. I'm going to try to fill in the blanks about the methods I'm using as we go, and hopefully give you a little bit about that. So this time series database, this time series data set, what does it look like? It's literally got a row for a timestamp, 2015, October 3rd, 10:04 in the morning. It has a number of coffees brewed to date, 11,211, and then it has a contributor. So when you install this Android app, it asks you for your name the first time, and that just sends an extra data point saying who entered that row in the data set. And so the questions we're going to address today: who are the contributors to this data set? Who is it that gave us data points? What are the department's weekday coffee habits? Is it Monday, it's a difficult day, after the weekend you come in, you have some coffee? Is it Friday, it's the last day of the week? And then how much coffee are people drinking in a per capita base? All right, so let's begin. If you're using an IPython notebook, you want to type this. If you're using Spider or a REPL or anything like that, you don't need that second line. What that second line does is it just tells Pandas and Matplotlib under the hood that if I ask you for a plot, just show me the plot immediately under the cell. All right, so let's run that. Everyone happy so far? Any questions? All right. So let's import some data. This is what all of our cells where we have to type things in look like right now. So I'm going to get rid of this. How to import data in Pandas? That's kind of the number one question. Pandas is there for data manipulation. We need to get it into the package. So the first thing we're going to do is we're going to pull from a data file called coffees.csv. And the easy way to do that is, hey Pandas, go read a CSV. All right, done, no errors, that went just great. Pandas is able to import directly from SQL. It's able to import HDF5 files. It's able to import from JSON and all sorts of other formats. Very, very flexible. What does the data look like? Well, the easiest way to check is just say, hey, Python, what does the data look like? And it looks like that. Now, that's a lot of data, and I don't particularly like the format of it. So I'm just going to skip ahead immediately and say, hey, data.head. Show me the first few rows of this data set. All right, so what we can observe immediately is we have an index on the left that's just running from 0, 1, 2, 3, 4, all the way up to the number of rows we have. And then we have three columns. The first one is the timestamp column, and that contains this kind of information here: coffees and contributor. Does anyone notice any problems with this data set?
Missing data.
I'm sorry?
Missing data.
Missing data. Right, missing data comes in the form of these nans. That means not a number. Probably at the CSV, there was nothing in that field. Anything else? Okay, so everything here is a float, whereas we'd expect coffees to be integers. How about this guy? Turns out, when I wrote this app, I didn't do any validation, so you could write whatever garbage you want. So that's not good. So we immediately have a few things we need to clean. All right, and that's what this says. So an index and three columns, and then you guys have highlighted already the three problems that are immediately apparent with this data set. There are going to be others, because no data is ever clean. All right, let's look at that string in the third row. We're going to use these methods called .lock or .ilock. So I'm going to do data.lock 2 because I want the third row. All right, and there it is. The third row has a timestamp, a coffees, and a contributor field. Does anyone know the difference between .lock and .ilock? One is strings and one is numbers?
And one can access.
Okay, so what lock does is it's a location-based accessor, and it looks for something that's present in your index. Now here I said lock of 2, and 2 is in my index, and it's my third row, so that's perfect. ilock is an integer lookup, and it's like accessing a list in Python or a NumPy array. You just pass it the index of where you want to go down the data frame. So in this case, I can do exactly the same with ilock and get the same data back. because index 2 points to row 2. Perfect. Everyone happy with that? So the number of coffees here is definitely a string. Something we'll have to fix. We'll come back to that. Let's take a look at that NAN. And in fact, why don't we look at that at the first 5 values in coffees. Now, coffees is a column of the data frame. So if I say data.coffees, what am I accessing here? I've got a series. So this is just the values in that column. And I can I can index them using square brackets like I would a normal list or an array. So if I say, hey, give me the 5 first, then we have the 5 first elements in that series. So the difference between a series and a data frame is that a data frame contains multiple columns, all of which can be viewed as series. And we'll be juggling the two quite often. How's my speed? Is everyone keeping up okay? Great. All right, how long is the data set? I've put in a little bit of a cheat here, but I think anyone in Python would know what to use if I wanted the length of any iterable. 671 data points. What else can we find out? Well, we've used .head to look at the first few rows. We can use .describe, and this can return a number of things based on what's in the data frame, but if we do it just as is, what do we get? Well, we get, it looks like another data frame actually. The index is a bunch of strings, but this is a data frame. There's a column for every column that we had, timestamp, coffees, and contributor. And then there are a few different objects in there. So there's a count. How many columns are there? How many objects are in the timestamp column? 671. And that's the length of our data frame, so that's great. But in coffees, there are only 658 different objects. And that's because we spotted some NANs, some null values. Contributor doesn't look like it's missing anything, so that's great. How many unique values? Well, we only have 9 different people contributing to this data set. Unique timestamps, it's great that they're all unique because in theory they should all be following each other and no 2 people should be using the app at the same time. And then the top and the most frequent, this is just the first value in the timestamp, and this is the most common value in the timestamp. And because they're all unique, they're all as frequent as each other, so here it's just picked a random one, and it said that the frequency of that is 1. But 2 people apparently entered that there were 7,216 coffees, because that's a frequency of 2. So we are missing some data, and so we're going to have to fix that. We can either drop those rows because they're not contributing anything, or we can try to interpolate over the NANs. And we'll do both today. But so a data frame contains several columns, and each of those columns can be viewed. So columns go down. Let me pull up. All right. This is a data frame. You can view the timestamp column as a series. You can view the coffees column as a series. In fact, why don't we do this? If I say, hey, data.coffees, I'm accessing the coffees column, and the type of this is a Pandas series object, whereas the type of the data is a data frame object. There are 2 ways to access a series from a data frame. I like the dot notation. I find it's nice and clean. But you can also access it using a string. Okay? All right. By the way, shout out as much as you like. I like the back and forth. Okay. So we spotted that we're missing values in coffees. So we're going to try to figure out where coffees is null and see if there are any patterns there. So my hint here is use the .isNull method and then Boolean indexing. What does this mean? Well, we have data and we can look at is null right off the bat. All right. Do we spot any trues anywhere? There's a true. So this is now asking for, is this value null at any of these points in the data frame? If I want it for the coffees only, what would I have to change? Say again? Dot coffees dot is null. Awesome. All right, and that's now returned a series again. Now the great thing about this is it's returned a series with the same index that we have on our data frame, and it's obviously the same size as we have too. So what I can do is I can use this as a Boolean index, and I can say, why don't you return to me the data where datas.coffees is null, just by doing that. And so I have pulled out all of the rows where coffees is null right now. It looks like they're spread pretty much over time. We start in October 2011, and then there's still some nulls in 2013. It looks like it's by a mix of contributors, and indeed we can confirm everything is null in there. So how about that problem with the strings in the coffees column? Well, I can say, hey, what's the D type? What's the data type of all of the columns in my data frame? And what do we see? That they're all objects. The contributor column makes sense that it's an object, because object is what Pandas uses when it means strings. But surely the timestamp column needs to be a datetime object. And it would make sense that the coffees column at least be some sort of numerical type, right? It should be probably an int. It could be a float if we really wanted.
What's the difference between the D types and the type?
So D types, so type is applied to an object. So here if I apply it to data, I get that data is a data frame. If I apply it to data.dtypes, I should get that's a series. And that's because if I look at what data.dtype on its own gives me back, it's a series where the indices are the names of my columns, and then the values are the type that that column is. So .dtypes is looking at the column, it's looking at all of the elements in that column, and it's pulling from that to say, these are objects, or these are floating point numbers. Dtypes should work on a series too, I think. Yep, dtype O is an object. Dtype comes from NumPy, if you've ever used that. NumPy arrays can contain floating points, they could be integers, they could be all sorts of different dtypes. So here what we're saying is, these are all objects, and that doesn't make sense. We want the data to be in the right format so we can analyze it correctly. So let's inspect what's in that timestamp column, because those timestamps need to be datetime objects. Python has a great datetime library. Pandas does a lot of great stuff on top of that. So we want to use it. So print the first element in the series. Well, let's see. Well, so the series it's referring to is the timestamp column. So if I say data.timestamp, that'll print the first element. And how about the type of the first element? Well, I can print the type of data.timestamp. And I want to access the first element here. So the first element looks like this, and it's a string object. Does anyone know why it might be a string object instead of a datetime? I imported it from a CSV. If you're not familiar with a CSV, it's like a really basic text file. Now Excel can open these. It's called comma-separated value. And it's just a list of all of your data separated by commas. And because it's a plain text thing, it's pretty dumb. And we don't know that these things should be datetimes. So they've been read in as strings. Actually, I consider myself pretty fortunate that Pandas was intelligent enough to interpret most of the rest as floats. So one more thing we need to add to our cleaning list is we want the timestamps to be datetime objects and not strings. All right, so this is everything we found so far that's wrong. The timestamp column contains strings, but they should be date types. The coffees column contains both null values, and we saw at least one string, so we need to clean all of that up. So that was our kind of first pass. We're going to do some cleaning, and then after that we'll answer some of those questions. Quick show of hands for how many people are following along in the notebook. How are you finding it? Speed is okay? Yeah? All right. Don't hesitate to shout out any questions. All right, let's clean this up. The coffees column should contain only numerical data. Pandas, ever wonderful, provides us with this method called toNumeric. So if I say, hey, take the coffees, take data.coffees, which is a series, and set it equal to the numeric of data.coffees, is it that simple? Is it really going to work? Well, the answer here is no. It's never that simple. But it's very close. All right, if we look at this error really quickly, we see that it was unable to parse a string testing. That was our string in the third or fourth column, right? Third and fourth row. What it's not saying is, I was able to parse all of those NANs. If I'm missing a value and you tell me to turn something into a numerical column, I'll just ignore those, because those are, an NAN is a valid number, surprisingly. But what it couldn't do is parse the string testing. Now, we're going to use something that's a keyword argument to numeric. We're going to say errors coerce. And what that says is anytime you find an error, just dump it and turn it into an NAN. And that's really helpful because we only had one string. I can tell you because I know the data set. You should have checked. But we only had one string, and it's not providing us any information. We don't know how many coffees there was on that time. So if I run this cell now, these are now numerical. And I can check that. Let me comment this line out, and then I'm going to say data.dtypes. We have now a numerical object. The whole column contains numerical objects. We don't contain strings anymore. What we do have are some NANs, and that's fine. We were expecting those.
So don't the data copy this series
So I've taken a copy of the coffee series. I've cast it as a numerical. And I've said anytime you hit something that you can't cast to a numerical by yourself, just get rid of it. And then set that back into the coffees column in my data frame. And I'm able to do that because this operation doesn't change the index, right? So data.coffees is a series, but it still has an index. And when you try to do equalities in Pandas, it compares the indices. All right, we solved one of our problems, and that was easier than I thought. So moving on. It contains some NANs. There are several ways to deal with these, as we said. One of them, you could just pretend they don't exist, just drop the rows. You could also fill in the rows, maybe by interpolating. If you have a value above and below, maybe take the mean. We can be more clever than that. Later, we'll look at the times and the dates that we have, and we'll draw a straight line between two dates, and then wherever our value lies along that line, that's the value we'll give it. So that's just an interpolation between dates, not between 2 points that are equally distant. But for now, we're going to start easy, and we're going to use a convenient method called dropNA. Now, if I drop NA as it is, it's going to return a data frame, and it still has our NAs. And that's because a lot of what Pandas does is it operates on copies of objects. And that's for safety. You often don't want to mutate things in place. But in this case, it's perfectly safe to do so. So I'm going to say, do it in place. And if I run that now, check out our indices. We've lost rows 2 and 3, and we've lost the index that belonged to them too. But now we've dropped any rows that contain a not a number. There are 2 ways to do this. This, as I said, was in place. You could also have done data is data.dropNA. Because this is actually working. This part is actually dropping the NAs, but then it's just giving you back the object and you're not holding on to it. That's what we did the first time. Now we're saying, just set it equal to data. Any questions on that one so far? All right.
What is the index? Isn't the index set because you're replacing the data frame?
No, because what this is doing here is it's dropping those rows, and that gives us this result, and then you're saving this result on top. So you keep the dropped index. You keep the index where you're no longer perfectly sequential. All right, so the coffees. We saw that was a floating point column. I will confirm that again. So let me cancel this, and let me say .dtypes, and it's a float 64. I want this to be integers, really. So what I'm going to do is use as type int. It's like speaking English. It's so easy. All right, those coffees are integers now. And again, I can look at the dtypes, and they're now 64-bit integers instead of floats. How about the timestamps? Well, if you've ever messed with date-time objects, you'll know they're generally a bit of a pain. You have to take the string and break it up into the year and the month and the day and the minutes. You have to drop the microseconds, because who cares? And then you've got to create a date-time object from that, and that's annoying. But once again, Pandas makes it pretty easy. We're going to say to date time. All right, and now we have datetime 64 objects in the timestamp column.
We have stuff like
To int, generally you want to cast it to numeric first, as we did. Numeric will default to floats if it finds a mixed type, and we had floats first, so it will go to floats. And then we do a as type int. And the reason is to numeric handles the case of error handling.
My question was, what is the difference between dot as type and to underscore?
So if I used .as type int, the first pass, it would have failed on that string. There is no toInt method. There is a toNumeric, and then you turn that into an int. Okay? Say again, you got dtype 60? Oh, okay. You're probably running on a slightly different version of Pandas that defaults to 32-bit integers. All right. Everyone happy with that? Yes?
I'm a little confused about the indexing. It looks like the index is in one sense not a column, because it draws three types. On the other hand, it seems to be a column because those are preserving when you drop rows. It's not just number sequence. So it's not just getting the array line. It seems to really have that data, and it's not getting back that data.
It absolutely has that data, and you do have that data. Let me repeat the question. The index that was non-sequential after we dropped some rows seems strange, but you have access to this. It's an actual piece of data contained in the data frame. And what you see here is we go 0, 1, 4, 5 because we dropped 2 and 3. You can consider the index a primary key, if you will. There's no guarantee that your index has to be sequential and well-formed and unique. But if you don't pass an index into a data frame, Pandas will create one for you, starting at 0 and going to the length of your data frame minus 1. And these objects truly are attached to the rows. And we'll find that that's really useful later. All right, everyone happy with this one? All right. So where do we stand? We did some cleaning. Let's use describe again. If I use describe, it's only describing the coffees column to me now. And that's because I have a coffees column, which is an integer. I have an object column for the contributor, and I have a date time column for the timestamp. And when Pandas is faced with different dtypes in its data frames, and you ask for describe, it will default to first the numeric values. But what I can do is I can say, I can include this include argument to see all of the information. And that just looks like this. Hey, tell me everything. So we have our count again. We saw count, unique, top, and frequent. All right, that was the first time we hit describe. And it's saying that the timestamps, there are 657 of them, there are 657 coffees and 657 contributors. That's because we've dropped all NAs. That's great. And then it's giving me a bunch of nans for, what's the most frequent value? Well, what does it mean to have a most frequent value for, something that's a continuous number? Generally, it doesn't mean much. So it's telling me, I can't tell you that. But it does tell me what's the mean number of coffees, what's the standard deviation, what's the minimum and maximum, what are the quartiles. So that's pretty handy. So we can immediately see we started at 397 coffees and we went up to 24,000 in a bit. What about the first few rows? Because we've done a lot of changing now. So how do I get the first few rows? Say again? I'm going to use lock. All right. So why did I need to use lock or ilock? Because this is a data frame. And if I try to access it without the square brackets, it's going to run through my index. No, it didn't. My bad. All right. So here are the first 5 rows. This is a well-behaved integer. These things contain no more, they never contain anything bad. We have no NAs here. And these are actually datetime objects, which again we can confirm using dtypes. Great. So we're in a place where our data frame is looking good. Things are as they should be. And the data is ready to do some analysis on. Is everyone following okay? All right. So, say again? Did we do something with a string?
String contributor, it's right now object, right?
It's an object. So
Convert it to string.
So an object is Pandas' notation for strings. Strings and other objects. All right, so at a glance, let's look at this time series. Why don't we begin by plotting it? So if I say, so the hint here is plot on the coffee series. So that's the data frame, that's the coffee series. Let's plot it. Is everyone managing to get a graph? All right. No? All right, hands up if you don't have a graph. Do you know what the issue is? Say again?
Time series is 100.
All right, I'll give you just a minute. While we're waiting, does anyone notice anything strange about this graph?
Time series.
It's a time series. It should be a time series. Why is it plotting 0 to however long our data frame is? It's plotting against the index. That's right. Also, something I want to draw your attention to is this little spike here. And we'll get rid of that in a bit. But okay, so it's plotting against the index, which is a series of integers. So it's doing something strange. It's not taking into account the distance between date times. Let's use the data frames plot method instead of the series plot method. And we can pass in the index. So my hint says plot on the data frame, which looks like that, setting x to the timestamp. And then a dot dash style. So I look something like this. All right. What have I done here? I've said, hey, plot the whole data frame. Use the timestamp column as your x. Plot anything numerical on the y, and here we only have one numerical thing, that's the coffees. And then style it with dot dash, which is basically a straight line and also dots where we have values. And the reason I did that is you can see that here there's an entire several months where no one's entered any data. And then here there are a few plateaus as well. I can explain these. This looks like Christmas break. This looks like maybe Easter break or something like that. This is where I left the University of Warwick. And this is when I came back and visited. That's not terribly useful. The resolution here is awful. So one of the things we're going to do is get rid of it. Yeah? Do I need a different date table?
Sometimes the graph, if there's a date with no object.
So we don't have that problem here because we don't have any dates with nothing in them. If you were plotting a series that contains some NAs, there would be missing chunks in the graph. Yeah. Okay, so let's inspect the last few points of this time series just to confirm it's what we thought it was. So we had .head earlier, but we can use .tail. And I'm going to pass in n equals 10 because I want 10 rows this time. And so here are the last 10 rows of this data set. And what do we see? March 4th, 5th, 8th. And then on the 12th, someone else contributed. And then someone else contributed sporadically for about a month. And then there was nothing for 5 months, and then I came back and visited. So that's what we thought it was. But just for simplicity, I'm gonna get rid of that tail because it's not particularly useful. It doesn't tell us that much. You may disagree with my choice on that, but because this is a really quick, dirty analysis, we're just gonna skip it for now. So I'm gonna get rid of everything after the 1st of March. And we're gonna use conditional indexing here. So what does conditional indexing look like? I'm going to blank these out first, and I'm going to say data.timestamp is less than 2013-0301. What's this going to give me? A series of true or false, a series of booleans. Excellent. That's what that looks like. All of the start of the time series is before March of 2013. Well, that makes sense. But we've already seen Boolean indexing. We've seen how we can use a series of trues and falses to index across the data, right? And that looks like that. That's another data frame. And if I look at the tail of that, it ends on the 27th of February. That's great. So we've chopped off everything after the 1st of March. Just want to bring you to the simplicity of this. We passed in a string as the date here, and Pandas converted that to a date time for us and filtered anything that was not less than that. Say again? These are timestamps with no time zones. So I'm going to cut off that tail. So I'm just going to say, I'm going to take this expression I had down here, and I'm just going to put it after the equals and say data is the same thing as data, but it's only wherever the timestamp is less than March 2013. And then if I look at the tail of that, that's healthy. That's good. So one final look. Why don't we plot the data against the timestamp? Do you remember how to do that? You plot. X is the timestamp. And I'm just going to leave it as is. We don't need the style. Actually, let's put in the style. Let's do dot dash again. All right, so we're good. And by the way, you can do things like you can pass in arguments for how big you want the plot to be. You can pass in a title. You can pass in labels. All this uses matplotlib under the hood to generate these graphs. So we see our Christmas break again. We see, damn, I took 2 months off. That's not good. And then we see another kind of Christmas break around here. Everyone happy with where we have the data set? All right, let's start answering that first question. Who contributed to our data set? So, I'm going to look at the contributors column. That's a series, makes sense. And series have a method called value counts, which just returns a series. It's indexed by the unique values within that series. So in that case, it's all of our names. And then it counts the number of times that unique value occurs. So that was a really quick way of counting over all of our individual contributors. But if you're like me, you like charts, and this is kind of hard to read. So why don't we plot it? So I'm going to do the same. I'm going to take data, contributor, value counts, and I'm going to plot, but I'm going to pass kind equals bar. So I'd like to thank Arturo for contributing.
You need to pass the x-axis.
I'm sorry?
You need to pass the x-axis.
Didn't need to, because when you plot a series, it plots against its index. And the index of this series is our unique names. Yep. So I didn't need to pass in an x value here. Everyone got to this point? Is anyone struggling, confused, behind? All right, a few people confused. Let me take two. What's up, guys?
Just the way you chop the tail off.
Okay. All right, I can go back over that. I'm just going to go over the chopping the tail off really quickly. All right, so here's the statement. I'm going to start in the middle of those brackets, and I'm going to say the timestamp of the data is less than March 2013. And for every row, you're going to say, yes, it is, yes, it is, yes, it is, no, it's not. And there's some point where you're going to transition from yes to no. I'm going to use that series of yes and no's to index my data frame. And so I'm going to say, only return rows where this index is true. And so it's only returning rows where the timestamp is less than March 2013. And then I'm setting that into my data. Alrighty.
You didn't give the counts, because you were gonna like remove some of the contributors that are not contributing in the data set?
I was going to keep it.
Okay.
I wanted to see who was contributing. Not because I like seeing my name up there, promise. No, it's just an interesting question. How did this data set get built up?
Question. I want to give this same per month.
You want to see the same per month?
Yeah.
Okay, so we're going to do some operations later called resampling, and we'll get things into per day and per week. Per month is the same. We're not quite set up for it yet. What we need to do is change our index to be a timestamp index, and we'll do that in a bit.
Another question is, do we have like a group by operator?
Do we have a group?
A group by operator?
Uh,
A group by operator.
this is a group by contributor, yeah. Okay. All right. So here's a question. We looked at who put these data points into the data set. How about on what days were people active in putting data into the data set? Does anyone expect anything interesting here? Just looking, Mondays, what do we think? Lots of data, little data? I think a lot of data. How about Sunday? Probably not. Though it is a maths department, people were there on Sunday. So the hint here says create a series of the weekdays for each entry. So I'm going to look at data.timestamp. Because this is a timestamp column, it has access to this .dt attribute. DT stands for datetime. And this opens up a whole world of new objects to us, one of which is .weekday. I'm going to blank those out for now, and I'm going to say, hey, I just created this. What does it look like? Okay. Does anyone know what's going on here? 0 is Monday, but very close.
0 to 31.
It's 0 to 6. It's because I'm asking for the weekday, not the day of the month. So, yeah?
Oh, so it's the number, the second column is the
Yeah.
of the week.
This is still the index of my entire data frame. All right, we've still lost 2 and 3. And over here, 0 is Monday, Tuesday, Wednesday, Wednesday, Thursday, 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 etc. So what I'm going to do, I know it's not particularly useful to have 0 to 6 instead of Monday to Sunday. We'll change that in a minute. But first, I want to save this data to my data frame because it's super handy to be able to refer and just say, hey, on any given row, what day was it? Well, I'm going to assign it to my data frame. So I'm going to use data.assign. I'm going to say, hey, the weekdays column is this weekdays object that I just created. And so then I'm going to look at the head, and I'm going to see I have a brand new column called weekdays, which contains the day of the week. Does that make sense? Why am I using .assign here? Later, we're going to use a more direct way of adding a column. Pandas is incredibly intelligent under the hood, and so what it does is it optimizes a great deal of operations. So when you use data from your own data frame, and you try to assign it in a new form to the same data frame, it may or may not give you a warning saying, hey, you're using a copy here instead of a view, or you're using a view instead of a copy. And what that means is if your data frame changes at a later date, you may be changing data that you didn't know you'd be changing. So often when you get that warning, it's worth heeding. Here I got the warning in the simple way to assign it. So I'm just going to say .assign, which takes a copy of that instead of a view and just slams a new column into place. Everyone following? All right, but as we said, 0 to 6, not very helpful. I created here a standard Python list, Monday, Tuesday, Wednesday, Thursday, all the way to Sunday. I created a dictionary that maps 0 to 6, which I got from range 7 here, to this string. So if I look at what that looks like, it's a simple Python dictionary going from 0 to 6 in the keys, Monday to Sunday in the values. And I'm going to use a function called apply. And I'm going to apply a custom function that I'm going to write to this column so that I can turn my 0s to 6s to Monday to Sunday. So how many people are familiar with lambda functions? All right, so I'm going to use something that's not a lambda. So I'm going to write a function. I'm going to say, hey, day of week, and it's going to take some index. I'll call it IDX. And I'm going to say, return weekday names of that index. Sorry, weekday dict of that index. Actually, it would be exactly the same to use just the list. But I'm going to do this, and I'm just going to show you that it works. So let's print weekday dict. Let's print day of week of 0, and I get Monday. And then of 2, I'm going to get Wednesday. Great, so that works. So now I'm going to use this apply method. I'm going to say, hey, data weekdays, you're going to become data weekdays where I'm going to apply a method day of week. So this is a function I wrote. It's going to look at the value in the weekdays series, and whatever that value is, if it's a 0, if it's a 6, it's going to pass that as an argument to day of week, and it's going to save the result on top of it. So now if I look at data.head, my weekdays are far more human legible. Any questions? Sweet. Okay. Let's group by the weekdays. All right, so the original question on this part of the tutorial was, on which days are people contributing? So now we have Monday to Sunday, and I want to group them up. I want to say, take all of the Mondays together and count them. Take all of the Tuesdays together and count them. Now that sounds incredibly like value counts, which we used earlier, right? So we could use that, but we're going to use this group by, which is an extremely powerful method that just brings anything together as you'd tell it. So you're going to say data.weekdays. Sorry. What did I want here? I'm going to take the data, I'm going to group it by the weekdays column. And let me show you what that looks like. Currently, that is a data frame grouped by object. It's not giving me any information. And that's because what I've said is take all of the values in the weekdays column and just group them up if they're the same. So now I have 7 groups. I have the Monday group, the Tuesday group, the Wednesday group, but I haven't said what to do with those groups. Well, the easiest thing to do is to count the groups. And now suddenly I have a data frame where, so I had 3 columns in my data frame. So why am I counting each column given that they all have the same thing? Why don't I take, I'll keep it for now. Let's try it. Let's try taking weekdays.group by. That doesn't work. Let's leave it as is. Boom. All right. So now what I have is a data frame where the indices are weekday indices. That's the title there. The Friday column contains 114 rows in all 3 columns. Monday is 145. Sunday is 13. I don't like the ordering though. Friday, Monday, Saturday, Sunday, Thursday, it's not great. So why don't we reorder that? Why don't we say it's weekday counts. And do you remember that list we had above? The list of weekday names, which is ordered? Well, I'm just going to use that. Yeah, okay. That's because all right, I'm sorry, let me cheat. I'm doing this on the fly, my bad. All right, cleaning the data. Where do we stand? Done that. If you can see that, this is what that lambda would have looked like. So a lambda is just an anonymous function. It's a function that I'm saying, here's a function, don't bother giving it a name, just apply it. And here's what that function does. Okay, let me go back here. What did I do wrong here? Well, this thing is a data frame, right? And if we want to access the data frame by its index, then we're going to need to use .lock. It was looking for Monday in the data frame. And it was saying, where do you want me to find Monday? I'm trying to access this by rows, by the number of rows. But you have to say, no, look in the index. And that's what that does. Can you say again?
Previous step.
Previous step. Yep. So previous step, we created this function that just returns a string when you give it an index for the weekday. And then we said take the weekdays and apply that function to it. So turn those things into that function. How many people are still with me at this point? Yes. All right. Is everyone happy with this step too? Okay. All right. Let's visualize these weekday counts. So we're going to do exactly the same as we did before. We're going to take the data we had before, which is this weekday counts data frame. And so I'm going to take the weekday counts, which is my data frame, and I'm going to plot it. And it says to plot a bar chart. So again, I'm going to pass kind equals bar. All right. Why do we have rainbow bars suddenly? We have 3 columns. They all contain exactly the same thing. That's kind of useless. Why don't I take weekday counts and only keep one of the columns? It doesn't matter which one I keep. I'm going to keep coffees because I like coffee. All right. So now we have 1 bar because we're only plotting one of the columns in that data frame. And what you can see is that Monday was definitely the day where people entered the most data. Wednesday spiked, surprisingly. And then Saturday and Sunday, people weren't really there very much, but that's not negligible, so that's pretty great. Questions? All right. On to the second question. It's going to get a little bit more difficult. We're going to figure out if there are any trends on when people drink coffee during the week. Now, the trend we just saw was when do people input data? That is, we were counting the rows, but now we want to count the difference in coffees between each row. I want to know on which day are people consuming the most coffee. So here's where it gets interesting. I'm going to take this data.index, which I showed you earlier was, it's just an integer index, and I'm going to replace it by the timestamp column on that row. So I'm going to say data.index is data.timestamp. So what have I done? I've replaced my index with, Pandas just created for me a datetime index, which contains all of my date times. Let's see what the data set looks like now. Well, instead of that 0, 1, 4, 5, 6, we now have dates. And remember, these aren't strings anymore because we cast them to date times. We also have the datetime column, which contains exactly the same information. We have the number of coffees, the contributor, and the weekday that that day was. Yes?
Are we working on coffee or the actual data?
We are working on the original data frame, which we've cleaned at this point.
So this is not go back.
I mean, we still have that object that was the weekday counts.
Oh,
It's still there, but you know, we've answered that question just about, so we're now answering a more difficult question, which is, I know you give me more data on Monday, but on which day are you going through my coffee beans?
I was talking about we can't get index.
Oh, the index is gone. If you try to index and say, give me the row at index 4, it doesn't exist. If you say, give me the row at exactly this index, it'll give me back that row. Yep, we now have a duplicate timestamp. That's, it's not needed, yeah. So that's why this next line here says, hey, why don't we drop it? Let's drop the timestamp because we don't need it. It's already in the index. I'm going to use .drop. .drop takes in a list of objects to drop. And usually it's going to look for these in the indices. It's going to say, oh, you wanted to drop the 4th of September. But here I'm saying, don't drop a row, drop a column. I'm passing in the column name, and I'm saying axis equals 1 means don't look at this axis, look at this axis. Look for the columns to drop. And then if you remember this in place equals true, back when we drop n8, we use that to say, so I don't have to say data equals this, just drop the column as is. Yes?
What happens if there are values in the index?
So that's a bad place to be if there are duplicate values in the index. It'll depend what kind of manipulation you're doing. If the type of things we're going to be doing today, it shouldn't matter if there are duplicates. But as we saw earlier, each value is unique. So that's great. Yep.
You had a timestamp, why didn't you draw the data frame?
Because a data frame cannot exist without an index, so I can't drop the index. So what I did is I copied the timestamp to the index, and then I'm going to drop the column. Yep. If I had a more complicated data frame,
So can you match your index partially, or do you have to have the whole date and time?
you don't have to have the date and time. If you had you could have a date time index where the times are all midnight. We will do that later. You can have timestamp indexes with time zones. The Pandas kind of date manipulation is pretty powerful. Yeah.
What is axis equal to 1?
Axis equals 1 says, when you're looking for this value timestamp to go drop, Usually, by default, it would look at axis 0, which looks at the rows. And so if you want to say drop 0, it would drop the row with the index 0. In this case, I don't want to drop any rows. I want to drop an entire column. So I want to drop something that's going down instead of something that's going across. So that's what axis equals 1 does. So if I run this now, I no longer have that timestamp column. I have timestamp in my index, and then I have 3 columns: coffees, contributor, and weekdays. All right, what I want to do now is, it gets a bit complicated. I want to insert rows every day at midnight. And the reason is I have a bunch of rows sampled at really arbitrary times, like 8:22 in the morning and 11:48 in the morning. But I want to get one value per day. And the best way I can think of doing that is adding in one day every single day at midnight, and then finding the value of the number of coffees at that point, and then dropping my rows that are not at midnight. Does that operation make sense? I will see it as we go.
Will we actually change the timestamp to just a day?
I could, but then I would be losing my time information. So here's an example. Well, so I wish I had a board. If you have, let's say you have 10 coffees today at 1 in the morning, and tomorrow at 1 in the morning you have 20 coffees. What's the value going to be at midnight? Is it going to be 15 or is it going to be 19? Well, midnight is closer to 1 in the morning the next day, so you want the number to be closer to that. So we're going to do a linear interpolation between the times. We're not just going to drop the times because they are useful to us. So here's how we do that. What you saw above was that I had a
So is that so that you always have a day, a coffee entry for every day?
Yep, so there are some days where I don't have anything, and that'll be problematic. There are some days where I have 5, 6, 7 entries, and we'll have to do something to merge those together. But more importantly, if I drop my times, then if there's a midnight somewhere, then I want to know the 2 numbers to either side of me, which one's closer to me. How do I draw a straight line between those numbers, and how do I figure out what value of coffees I should be at midnight? So this is a daytime index, and the first one's at 8:22, then 11:48. So we're going to create another index, and this index is going to live outside of a data frame. First of all, we're going to create a date range, pandas.daterange. And it's going to start at data.index0, which is the first value of the index. It's going to end at data.index-1, which is the last index. It's going to have a frequency of days. And then it's going to normalize equals true. What this means is make these data points at midnight. All right, and so these things no longer have a time now. They are just days, but they are 1 a day, every day, from the start of my series to the end of my series. Let me show you what normalize equals false would do. Everything's at 8:22. Now we could do that, that's fine, but it doesn't make much sense. So I want to keep it clean, have just days. Let me show you what happens if we have a frequency of W. What do we get? Every week. Yep. Days is what we want. Okay. It's a datetime index of datetime 64 D-type of frequency days, and there are 514 days. Everyone following? Yes?
Why can't you use dot loc instead of dot index?
Because .loc returns something that's inside a row, and the index is separate from the row. So if I did, let me kill this. If I say data.index0, I get back that very first timestamp. If I did .log 0, well, 0 isn't in my index. If I did .ilog 0, I get the first row. But there's no timestamp information in that row. It's hidden away in the name of this series, which is less useful. So I'm using the index directly, because I can access that. So that looks like this. Yes?
Once again, why normalize?
Just because I want to keep things clean and have one day at midnight, today. I don't want to present anyone my report and say, hey, here's a list of every coffee drunk on every day. By the way, the day starts at 8:22 a.m. That doesn't make much sense. All right. So we have this index of days. And in our data frame separately, we have an index that's kind of randomly spaced. Uniform, it's not a uniformly spaced data frame where every data point, every row has the exact same interval between it. That's what our new index is for. So what we're going to do is we're going to create a new index that takes the union of both of those. All right, so our previous index was called midnights. So I'm going to say, hey, take the index called midnights and take the union with our index. That is, come up with a new index that has the values of both of these indices together in one index and make sure it's sorted in order. And that's what that looks like. So we start on October 3rd at midnight, and then we have October 3rd at 8:22 in the morning. Then we have October 4th at 11:48 in the morning. October 5th at midnight. All right, you see how this is going? Cool. Everyone still following along? Great. Yes? Can you speak up, please?
The granularity of the time will be denoted to the lowest one.
Frequency equals none is what it says for the granularity there, and that's because these things are not uniformly spaced.
Before midnight doesn't have hour and minute.
Yeah, before midnight it doesn't have a time, it's only a date. If you mash together a date and a date time, it's going to give the date midnight. Yeah? So that's why everything here defaults to midnight. I don't have any duplicates on this one. Not unless somebody put in an entry exactly at midnight. We worked hard, but I don't think we worked that hard. So, yes? So if we turn it into midnight, why are we still seeing these random times? That's because this is midnight's unioned with the current index. This is midnight plus all of the stuff we currently have. Now, what I want to do is I want to take my data frame, which is indexed at random times. I want to slide in some indices that are very regular. And then I'm going to have a data frame full of data and nones, because I don't know what happened at midnight, but I know what happened at 8:22 in the morning, just before that. And so what we're going to be able to do from that is fill in all the blanks. So I'll show you that in a minute. So what we can do is re-index our data frame. So our data frame is still called data. So I'm going to take data and I'm going to re-index it on our new index. And let me show you what that looks like by showing you the first 10 rows of that. Our first time is October 3rd at midnight. We don't know how many coffees. We don't know who the contributor was. We don't know what day that is. That's because I've just invented a row, and I haven't given it any data. The next is a row that we actually had. Then it's another midnight. We don't know what the information is. And then it's a row we had. So you're starting to see what we can do here. We can say, well, I want to fill in this coffee value here, and it's somewhere between 8 in the morning on the 3rd and 11:48 on the 4th. Find me a value that fits in that gap. Everyone happy with that? So Pandas didn't invent any data for us. It just filled everything in with I don't knows. How many people are familiar? Yep. Is none the default? Yes. So what I could do here is, I'll show you this on the fly. You could fill nulls with 1, 2, 3. All right. Great. And that's useful because sometimes nulls actually mean something informative, like my machine was broken. In this case, it just means I'm creating dates and I don't have a reading for that date. So we're going to fill those in. How many people are familiar with interpolation? Okay. So interpolation is saying, we need a board. I have a number of points, and then there's this little gap where I don't know what the value is. If I look at the points nearby, the simplest kind of interpolation is called linear interpolation. I look at the point to the left of me, the point to the right of me, and I take an average. Now, I take an average makes sense if I'm equally spaced between all of my points, but as we can see, we're not equally spaced. So we're going to do interpolation across time, which is to say, plot this against the time axis, and then wherever the line is, take that value instead, which is going to be between the value before and the value after, but it might be closer to the value after if the time I'm sampling at is closer to the value after. Alrighty. We're going to fill these nouns using interpolation. So my hint says interpolate the upsampled data using the time method. Could it be as simple as take the upsampled data, dot interpolate, method equals time? Why, yes it is. This value existed, this value existed. Here's a midnight. And that's a weird number of coffees, but that is the number of coffees interpolated between these times. We can turn it into an int. I'm not going to bother just because I'm just going to plot this. But so the cool thing here is if you take the average of these two numbers, it's lower than this number. This number is closer to this number because midnight is closer to this time than it is to this time. So we've maintained our temporal information as we interpolated over it.
You need the datetime and index to do that? You can't say specify column that has datetime value?
Yes and no. You can specify a column to interpolate over, but there are some of the more complex methods like time. I call it complex. It's not really that hard, but some of the methods that aren't just straight interpolate, they will give you a warning and say, you can't do this. So let's see. What happens if I take upsampled data.interpolate method equals nearest, for example? That gives us, here it's using the time index again. So if I say, I just want to interpolate the coffees with the time method, I think, oh, it works here. Okay, so I used a previous method earlier, maybe one of the quadratic methods, and it wants to use the index for more complicated things. What we'll see later is that it's just nice to have an index that represents what you're actually indexing on.
Pandas now understand that the index is a time.
Yep, because we cast it to date time. And if you remember, if we look at the index, then the objects are date time objects, and it's a date time index. So it knows how to do time interpolation. Alrighty, so that's where we stand now. We filled in all of those nouns. Yes?
I'm a little bit confused with the nomenclature of time. There's nothing inherently temporal about any interpretation. You have two spatial points that I want to that are in some other column, not even part of the index.
Okay. So the method equals time means you're going to be doing a linear interpolation where the x-axis, instead of being an arbitrary index of points, is a time value.
If I want to do linear interpolation, do you need arbitrary floats and do you need arbitrary columns?
You could use nearest, I think, or you can use linear as a method. I think the default, let me see, what does the default look like? The default here is using time as well, because it's nice and clever. Let's try a quick hack. Let's say my data frame is is my upsampled data, and I'm only going to keep the coffees column, and I'm going to say that the index is going to be that. And what does that look like? All right, so now we have, hold on, I want to do this before that, so I want to use data here. All right, now we have the number of coffees. And let me set, okay, that's fine. That didn't work. Do someone else have most there? Got me thinking on the fly here. That's not very nice. Okay, has that worked? This is still not going to work, is it? Oh, no, it is working. I just keep resetting it every time. Because I'm clever. No! I give up. We'll look at it later. Just in the interest of time, I'm going to keep going. Come on. Yes, okay, all right. We have a nan. All right, let's do some interpolate. If I just interpolate, that looks like exactly the mean of these two values. Okay? What interpolate did by base here is it said, I don't have any information on which I can do this. I'm just going to pretend I'm equidistant between point 0 and point 2. That is basic linear interpolation. What we did with the dot time method is we said, use your index. It's a time index. Time tells you how far points are from each other because these rows are not equidistant from each other. Use that to do your linear interpretation. Have I answered your question?
Almost. I wanted to add a different column with floats in it, and I wanted to use that as the interpolation.
Try it. Yes, that will work. You may come across a problem where you have to set that float column as your index depending on the type of method you're using to interpolate. Because over here, let's see what we have. All right, so here's that. I don't have a note on it. Pandas, interpolate. Let's look at the data frame one. So here are all of the methods you could use. And here's the one we used, time. Interpolation works on daily and high resolution data, so that means anything with a time, to interpolate the given length of the interval. If you used linear, you would have ignored the index and treated the values as equally spaced. So had I just read the docs, I could probably have done that from the start. Here was that method we used. Let's use linear. Still using the time, isn't it? Still using the time. Okay. Yeah, tell you what, I've already interpolated my nans. I'm not going to bother putting them back in. Let's come back to it. I just want to make sure we finish on time. Okay, is everyone happy with filling in the nans as we've done so far? Yes. All right. We're now ready to resample it at a daily frequency. Now, if you remember what we had, so this would be daily if I had these rows here and then this row. but we have all of these extra things. So we're over daily right now, and we don't want that. So I'm going to create a data frame called daily data, and it's going to use the upsampled, and I'm going to resample from it, and I'm going to resample daily, and I'm going to use asFreq. All right, let me show you without asFreq first. This is a datetime index resampler, and this looks curiously like our group by object from earlier. That is, it's an object that kind of has mashed some things together, but it's not giving us any information. And that's because this is very akin to a group by. This is saying, look at the timestamps, bin everything into days. Just group them into day. If these two rows fall into the same day, put them together in the same group. But I haven't told you what to do with the group. So I could do several things. I could take the mean of all the bins in the group, or I could use, say, the count of everything in the group, which we've already done. But what I'm going to do is I'm going to say asFreq, which is basically saying resample daily and only take the midnights on that day. So that's very helpful because we've put in the midnights and we've inferred the values at those midnights. So we're very happy with this now. And as you can see, we have lost our time information in our index because we don't need it anymore. Everything is equally spaced one day apart. All right, well, we now have a contributors and a weekdays column, which we don't need. And the reason we don't need them is they're full of nouns, they don't contain any information. So here I'm only going to drop the contributor column. So I'm going to say daily data is daily data dot drop contributor. Axis is 1 because we're dropping a column, not a row. If I look at daily data now, we've dropped that column. Excellent. And then I'm going to generate a column for the weekday names. Because remember we had these weekdays, and we figured out the weekdays were from 0 to 6, and then we applied a custom function. Well, I cheated you, I lied. There is a weekday name attribute, which gives us that information automatically. So what have we done here? We've said, take the weekdays column and set it as the index.value name, index.weekday name, sorry. So you take the index, which is a list of dates, and then you say, what's the day of the week for each of those? And so we have that information back. So now what we have is our original data set, but instead of being sparsely sampled at weird times, it's now uniformly homogeneously sampled at midnight on every day. Yes?
What happens if you really get some values from the midnight time?
If you have some values for midnight, when we took a union, I believe it acts like a set, which is to say that it only keeps unique values. So you would have had the number of coffees on that date at midnight, but you would only have had one midnight. Excuse me.
So can you explain again with the resample and asFreq?
So resample basically says, it's like a group by. And it's a bit more complicated than a group by, because on a group by we said, look at the unique values in this column, Monday, Tuesday, Wednesday. And any row that has a Monday, group them into the Mondays. Any row that has a Tuesday, group them into the Tuesdays. And then do something with those groups, like count the number of things in those groups. How many things came out on a Monday? That was group by on the day of the week. Resample does very similar, but it creates the groups for you. And here it's creating groups that are spread apart by one day exactly. So group anything that landed on the 4th. If you had 3 things on the 4th, 3 people submitted coffee values, put them into the group of the 4th. And then you could do mean, which we did. And that would just say, for the row that should be the result of that, on the 4th, take the mean of everything else. We didn't want the mean, because if we had an 8 o'clock, a 9 o'clock, and an 11 p.m. coffee, we don't want to take the mean of that and say that's what happened at midnight. We have the values at midnight, and we want to keep only the values at midnight. And that's what asFreq does. It basically says, Okay, so on the 3rd or on the 4th, you had 3 values. One of them was at midnight, one of them was at 11 in the morning. Only keep the one at midnight. It's like saying, give me this resampled at a daily frequency, as frequency. Yeah. You're gonna have to speak up, mate. What is the unit? Number of coffees made up until that date. And the reason it's floating point now is because, well, one coffee was made at 11, one coffee was made the next day, and this is pretending that that happens at a uniform rate.
For example, here it works because the index is time, right?
Yes.
So it's possible to specify an expansion in simple method.
Resample has an on keyword. So you can resample on a column.
So what happens if that updates?
It's going to say, I don't know how to interpret strings as dates. Or it might be clever and try to cast it for you. Okay. Any other questions on that? All right. So let's plot this data. Let's see once more what it looks like. And I think I called it daily data, right? All right. That looks like what we had before, except now we know that the data for the coffees is no longer an integer, and we know that the times are no longer sampled sparsely. We know that they're not at random times, and I can show you that by, again, putting a plot sign on it. And remember these plateaus for the Christmas break and whatever? We don't have a gap anymore. We still have something for New Year's Eve. We have a number of coffees. It might not be the exact number of coffees, but we have a value. We've done a reasonable estimate. Okay, how many coffees were made on any given day? Well, what we have is a series of how many coffees were made up until that day. How many coffees were made today? Well, it's however many we have today minus however there were yesterday. And that's just the diff. That's just, oh, I'm getting ahead of myself. All right, that's later. Let's group by weekday, first of all. So, so coffees by day is going to be, do I want to do this? Okay. It's going to be my daily data dot group by, is it called weekday? Yep, it's called weekdays. And then I want to take the mean of it. All right, that's not particularly helpful. I missed a step. Say again? Have you guys got this differencing cell? Okay, let's put it in. All right, let's do this. Okay, so what I want to do is I want to use this. Oh, here we go. Okay. Okay, here's what we should have. So we're going to use diff on the coffee column, and then we're going to follow up with a shift, and I'll show you why. So first I'm going to say coffees made is my daily data dot coffees, so the number of coffees we have, dot diff, and what diff does is it just looks at the difference between any two rows. And if I look at coffees made, that looks like this. So what it's done is it said, let's look at the difference between this day and this day, and put that into this cell. Then let's look at the difference between this day, and let's put it into this cell. Now, I have two nans here. The first nan I already had, because I interpolated from a midnight that I didn't have data for prior to. But this one I shouldn't have. And I have this because the difference between these first two rows, I want it to land on here. I want to say, the 3 o'clock at midnight, sorry, the 3rd on midnight and the 4th on midnight, the differences in coffees should be attributed to the day of the 3rd, not the day of the 4th. So we're going to use a shift, and we're just going to shift everything by -1. Shift all of that up 1. Great. So that's coffees made. And what that says is on the 4th, 34 coffees were made. On the 5th, 55 coffees were made. Bet you these are Saturday and Sunday. Let's add that as a column. Column is coffees made today, and it's just going to take that coffees made series we just created, and then I'm going to look at my data frame again. And now I have a new column with all of that information in there. And I was right. These were Monday, Tuesday. These are Saturday. So Saturday and Sunday are low. Monday, 10 times as many coffees as Sunday. Cool. So far, everything seems to be in order. Everyone happy with what we just did? All right. Now we can group this. So we're going to group by weekdays. And what does that look like? That's another group by object. What we've said is anything that's got a Monday in the weekdays column, group it into the same bin. And now, why don't you take the mean? Consider that every Monday is equal how many coffees were made on the average Monday. 34 were made on the average Friday. 37.8 were made on the average Monday. The average Sunday has a mere 15 coffees made. Starting to get a bit of insight out of this. But we're going to sort that out because we didn't like that. So coffees by day is going to be week. All right, so remember we had that list, Monday to Sunday? Yeah. 2 slides. Here I did not use a sign. So what happened was this calculation on the top row. This returns a copy. Simple operations will return a view, and what that says is, it's like pointers if you're familiar with that in C or C++. You have, your data actually points to somewhere else, and then it calculates things on the fly for simple operations. For complicated ones, here I'm doing a diff and then a shift, and the shift is going to break things. The shift is going to say, I'm just going to wrap this around 1, I'm going to create a new object for that. And therefore I was able to safely assign this column here. This is most often, I would say. In my experience anyway, I've been able to use this most of the time. Occasionally I get this weird warning and I have to dot assign it to do that safely. In the notes on these slides, there are a couple of Stack Overflow posts, and you'll see the people explaining why you want to do this, when you should heed the warning. Sometimes the warning is ignorable because it raises false positives. Yeah. Alrighty. We've grouped them up. We know how many coffees are made on the average day, but again, it's going Friday, Monday, Saturday, so we're going to sort that out, and then we're going to plot coffees by day dot plot, and we're going to plot another bar. What did I do? All right, coffees by day. Weekday names is a list, that's fine. Coffees by day is a data frame, so I can't access it that way. So I'm going to access using the index. That's much better. And then I can plot the bar chart. And did I break everything? Oh, I want to plot only the coffees made today. I don't want to plot the total coffees. There we go. All right, so we're back to what we had before. Monday, on the average Monday, 37 coffees are made. Tuesday, a little bit more. Wednesday, big spike. Hard day. Wednesdays were seminar days. Someone would come and give a talk at lunchtime, and everyone would sit around a coffee first and discuss things. So that makes sense. I'm glad. Thursday was clearly the hard day, and then Friday people slacked. Alrighty, last couple of questions. How many coffees did people drink? And this is where we're going to see a little bit more of the power of Pandas here. Often you don't have a nice clean data set in tabular form. You'll often have 5, 6, 7 different places to source your data from. The indices won't match, and you still have to join these together. So we're going to do a join here. First we're going to load in this data set called people, which just contains a daily index and the number of people in the department at the time. So if you remember how to do that, we're going to read, this is everything Pandas can read from, by the way. But we're just going to read from CSV again. And it's in data department members. And that looks like this. It's once a month. At the end of August, there were 12 people. At the end of September, there were 14 people. Okay? Really nice, simple data set. How do we join something that's monthly to our data set that's daily? Well, first we're going to do an outer join. Does anyone know what a join is? Okay, that was a bad question. So what a join is going to do is it's going to look at 2 data sets. It's going to compare one of the columns that you're telling it to look at. Generally, that'll be the index, but you can tell it to look elsewhere. And you're going to say wherever these indices match, extend that row. The default in Pandas is an inner join, which is to say, if my first data set has an index which doesn't appear in my second data set, drop that row. An outer join does the opposite. It says if this one has an index and this one doesn't, keep that row and just fill it with nan. So we're going to do daily data is daily data.join, and I'm going to join people, and I'm going to do an outer join on that. What does that look like? Let me just see what that looks like. All right. So what we have is, on the 3rd, we have this nan we had before. On the 4th, we have everything that looks fine. And then we have a bunch of nans for dates and members. Well, so the date here is going to be nans all the way down until we hit the end of the month, because that's when we had our data. But so one thing we can do is interpolate over using the nearest. And I'm using nearest here because no? Okay. I'm using nearest because the points are now equally spaced. So if I look at that, that breaks. Did I miss a paren? Paren is there, it's just not showing over here. So I'm using this new notebook edition. So this is a Jupyter notebook, but I'm using it in slide mode, and I'm running it live at the same time, and occasionally things are difficult. Let me take this. How does it differ? It doesn't differ. Oh, yes, you're right. When we loaded this in, I forgot to read half of my instruction. Parse the dates. All right, well, let's say the index column is the column called date, and parse dates equals true. So let me space that out a little bit.
So that's a cheat you didn't show us earlier.
That's a cheat. We're cheating all the way through. All right, how does that look? All right, this has changed. The date is now our index, because we said the index column should be the date. And let's just confirm that it's what we want it to be. How about the index? It's a date time index. Excellent, it's managed to parse those dates. So our data frame looks like that. And now we can do a join. So this should be correct. So we're going to take the daily data, which we had before. That's the coffee data. we're going to join it to the number of people in the department in an outer join. Let me show you what that looks like. And I can't do it twice. No. So that looks like that. So on the end of August, we had 12 people, but we have no idea how many coffees we were on. The end of September, no idea how many coffees, but we had 14 people. And then 1st of October, we started recording coffees, 3rd of October.
So when you're drawing, what do you draw?
Without arguments, it's joining on the index. So because it's an outer join, it saw this and said that this doesn't exist in my daily data. So create a row that has a bunch of nans in it. And then from the people data, that's where I got the index from, put that in there. Good question. So there is an excellent article on, here we go, it's called Merge, Join, and Concatenate. And it will run through every possible example of however you possibly want to join your data in every different form. It is incredibly elaborate. You can ignore the index. You can just shove columns on and don't worry if they're aligned. You can do all sorts by group keys. Anyway. The one thing I want to do now, though, is I want to interpolate over this members thing because we have a bunch of nans which we don't particularly like. We want to fill those in. So we're going to say daily data is daily data.interpolate. And I think I want to interpolate, sorry, daily data dot, let's just try interpolate method is nearest. All right, here's the head of our data frame. Let me have a few more rows. We had a bunch of nans here, but now they've been filled out. And they've been filled out to 14 because on this date, there were 14 people. Here we didn't know, but the nearest is 14. Here we didn't know, but the nearest is 14. So we've interpolated by just pushing that forward. It didn't interpolate on these 3 nans because there's nothing above it. And it didn't interpolate on these because this is a string. Okay, everyone happy with that? That's just an interpolate as we did before. Let's create a column from the number of coffees per person. This is an important question. So, coffees per person is going to be daily data dot coffees made today. And what am I going to do with that? Divided by daily data. Can I do this? Daily data divided by, so coffees made today divided by members, which is the number of people in my department. And now we have a coffees per person column. And on this Tuesday, it was 2.4. On the Wednesday, seminar day, 4. Looking good. And again, I can show you a few more rows. Thursday was exceptionally nasty. And then Saturday and Sunday, we didn't have that many coffees. All right, starting to get close now. Let's plot it. So daily data dot coffees per person dot plot. And okay, what is going on? All right, I'm going to ask for a little bit of input. What is going on with all of this up and down nonsense? Say again? It's not a discrete data problem. This is a weekend effect. All right, what you're seeing is the drop at the weekend and the raise during the week. It's hard to see, but that's what it is. What about here? So is it vacations? Is it market days? Is it that the machine is broken? Sadly, this occurred to us a few times, and we were all very desperate by the end of it. But I have that data for you. So let's use read CSV to figure out data.coffee status. And I'm going to read the full instructions this time. So parse dates. So I'm going to pass an index call is again the date, and I'm going to parse dates. It's true. What does that look like? Parse dates, plural. All right. Status is okay on those first 5 days. Well, that's great, but that doesn't tell us much. What are the values in this column? Well, we can use machine status dot status. That is the series, remember? And we can do a value counts on that. So there are only 2 statuses, okay and broken. It could also be a little crying face. But 88 days the machine was broken. Let's plot that. I want to see when things break. I'm going to do a little trick. I'm going to say numerical status is the machine status dot status equals okay. What is this statement doing? Zeros and ones, trues and falses. This is going to say, for every row, when the status is okay on that row, return true, and otherwise return false. And fortunately, trues and falses, zeros and ones, can be plotted as zeros and ones. And so here we have over time, because our index is a date time index. We have 1, it was okay, it was okay, it was okay, it broke for a little bit. It was okay, it broke, it came back for a few days, it broke again. I remember that time, it was very sad. All right, we have this plot. Let's join it to our growing data set. So let's say daily data is daily data.join on machine status. It should be as easy as that. Great. So here's our status. And let's bring in that numerical representation of trues and falses rather than okay and broken. So I'm going to say daily data dot status is equal to okay. Same thing we did to create a series, but now I'm just putting it straight into a column. True, 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 true. We have a false here because we didn't have an entry on this date. And that's okay. What we can do now, though, is we can plot both of those things on the same chart. So this is called daily data. I'm going to take daily data, and I'm just going to plot it as is. And actually, I'm going to plot both columns, because here I have overpowering everything is the number of coffees made to date. How do I select 2 columns? I pass a list to the index. So I'm going to pass status and coffees made today. All right. Plotting status didn't help because it was okay and broken. But what if I pass the numerical status? Let me go and do daily data.numerical status. I'm going to times you by 100. All right, that looks better. All right, so whenever this blue line crashes down, the machine is broken. And we can see that coincides spectacularly with these moments where people didn't drink coffee. So we're happy with that.
Are those values like true zeros on there? Like when you didn't have coffee? It says it's broken, but it looks like there's coffee before it's made.
And that is due to us interpolating on daily basis. So the diff is not 0 because by the time I started measuring again, the machine had been back and some coffees had been drunk. And we spread that diff out across those days. All right, strong weekend effect. Didn't like it. Why don't we resample that? So why don't we say daily data, so weekly data is going to be the daily data dot, I'm going to resample daily, resample weekly now. And remember, resampling weekly is going to say, create a bin for every week. Every data point that falls within a week, group it into that bin. And then I'm going to take the mean of all of those points that fall into those weekly bins. And then I can say weekly data dot plot, and I'm going to plot, again, coffees made today and numerical status. So that's that data frame, and I'm going to plot it. All right, so blue is our coffees made, and it's much smoother than it was. Now, I'm going to ask you to squint a little bit and say that, oh, across time here it was fairly constant. Maybe a little bit of like the post Christmas rush to get some papers out. And then what's this dip here? This dip happens during the summer months. That's conference season, it's too nice to be working on outside. And then these crashes, they've smoothed out a little bit because we've averaged those too. We've made those weekly bins, but they still coincide very, very well with where those coffees are not at the usual level. So just to wrap up here, what have we achieved today? Well, we started by cleaning the data sets. So we cast columns that were incorrect types to their correct types. We dropped some rows with no data. And then we truncated the time series when things got a bit weird and people stopped submitting data. We explored the contributions. So we discovered who contributed to the data set, how many people, by how much. And we established when, on which days of the weeks were those contributions made. We explored the time series by resampling to a daily basis. We interpolated over those missing values to figure out what those values should be. We discovered on what days of the week coffee was primarily popular, and that was on Wednesday for the seminars. We joined the data set to others, and that's always half the battle anyway. And then we derived some new columns from existing ones. We smoothed it out by downsampling. And so the insights we got out of this was there weren't that many people contributing to this data set. It was 9, but given that on most days we had maybe 12, 13, 14 people in the department, that's pretty good participation. Contributions were lacking at the weekends, and that's because nobody was at the office. Mondays had the most contributions. And seminar Wednesday is a strong driver of coffee consumption, makes sense. Periods of low coffee drinking, they matched up with periods when the machine was broken. And there was a dip in the summer months as people were away. So I'm just going to wrap it up there and take any questions you might have. Thank you.